In early 2026, an artificial intelligence called the same broken tool 400 times in 5 minutes, all by itself. Nobody told it to stop, because nobody had to approve each step. That is what makes an agent different from a chatbot. Here is the strange part. The difference between a chatbot and an autonomous agent is barely 6 lines of computer code. A chatbot answers in a single pass. 1 question in, 1 answer out. Then it forgets everything and waits for you. Ask a chatbot to find 3 flights, check your loyalty points, and book the best one. It stalls at step 1. It can explain flights. It can explain points, but it cannot act, because each prompt is processed alone, in total isolation. An agent takes that same language model and wraps it in a loop. Act, observe the result, decide what comes next. Back in 1995, researchers defined an agent as anything that perceives its environment and acts upon it. The key word, acts, not responding, acting. A chatbot is one call to the model. An agent is the model calling tools until the job is done. So what exactly happens inside that loop, step by step? That one question took the research field decades to answer cleanly. The loop runs in 5 stages, over and over. Perceive, reason, plan, act, and observe. Then it starts all over again. Perceive, the agent takes in what just happened. A message from you, an error message, or the result of its last action. Reason. The language model reads everything in its context and decides what should happen next. This is where the thinking lives. Plan. For complex jobs, the agent breaks the goal into smaller subtasks before touching anything. Simple jobs skip straight to action. Act. It executes something real. A tool call, a database query, a web search, or a piece of code it just wrote. Observe. It examines the result. Did that work? Is the task finished? Does the plan need to change? Then it loops back. In 2022, researchers at Princeton and Google formalized this as REACT, reasoning and acting, interleaved in one continuous cycle. The numbers were striking. Letting a model reason, act, and observe improved task success by 34% on one benchmark alone. The model does not just pick a tool. It reasons about why, executes the call, reads the result, and reasons again. But a loop with nothing to hold is just a model talking to itself. What gives an agent its hands? Tools are the hands. Each one is defined by a name, a description, and a strict schema of parameters it accepts. The model reads those descriptions and decides, on its own, which tool to call and exactly what arguments to pass it. Every tool falls into one of 3 families. The first family retrieves database lookups, vector searches, documents pulled into context. The second family acts on the world, writing records, calling outside services, executing code. These are the tools with real consequences. The third family is stranger, orchestration tools, where one agent's tool call is actually another agent summoned to work beneath it. For years, every company wired tools differently. Then one open standard emerged, the Model Context Protocol, now adopted across the industry. Think of it as a universal port. Any agent can discover and connect to any tool that speaks the same protocol. Here is the sentence worth remembering. The tools you grant an agent define exactly what it can and cannot do. That list of tools is the primary safety lever. Hold that thought. It becomes the whole story a little later. Hands and a loop, though, are still not enough. Without memory and a plan, every step forgets the step before. One researcher compressed the whole field into a single formula. Agent equals model, plus memory, plus planning, plus tool use. The loop is just the runtime, the engine that ties those four parts together into something that can finish a job. Memory comes in layers. Short-term memory is the working context, the goal, the steps taken so far, the results observed. Long-term memory persists across sessions, preferences, learned facts, past outcomes, stored outside the model and pulled back in when relevant. Planning has a cost problem. Reasoning at every single step means calling the model at every single step, and calls cost money. So engineers split the roles. A planner drafts the full task breakdown up front. An executor works through it, step by step. A replanner watches for reality diverging from the plan and adjusts. Planning up front, correcting only when the world pushes back. One system that streams tasks as a dependency graph reported a 3.6 times speed up over reasoning at every step. Memory, planning, tools, and a loop. At this point, the agent is complete. So naturally, engineers asked, what about several? What happens when agents start delegating to other agents? The answer is spectacular. And it is also where things start breaking. The orchestrator pattern. One lead agent reads the mission, splits it into threads, and spawns worker agents to explore in parallel. One research system built this way outperformed its single-agent version by 90.2% on internal evaluations, nearly double. Another design runs two loops at once, an outer loop for strategy, an inner loop for execution, resetting when progress stalled. Now the bill. A single agent burns roughly 4 times more tokens than ordinary chat. Multi-agent systems, roughly 15 times. Every trip around the loop is another call to the model. Autonomy is not free. It is metered by the iteration. Which brings us back to that broken tool and the 400 calls. Here is what actually happened that day. An agent was scraping a website. The site changed its layout overnight, and the scraping tool started returning nothing at all. Its instructions said retry until you have the data. No limit, no budget, no exit. So it retried 400 times. A maximum of 3 iterations would have stopped it instantly. Production agents, layer limits, iteration caps, token budgets, no progress detection. Remember the safety lever? Tools decide what an agent can do. Stopping conditions decide how long it keeps doing it. So when should something be an agent at all? The industry's honest answer is far less often than you would think. If the steps are fixed and predictable, you do not need an agent. A plain pipeline is cheaper, faster, and safer. Anthropic draws the line cleanly. Workflows follow paths written in advance. Agents direct their own process and choose their own tools. The published guidance from the biggest labs agrees. Start with the simplest thing that works and earn each layer of complexity. Agents shine on open-ended problems, where nobody can predict the number of steps, and the path must be discovered by walking it. Here is the quiet punchline. OpenAI, Anthropic, Google, Microsoft, and Meta have all converged on this exact same loop, independently. Different names, different toolkits, one identical heartbeat, a model, calling tools, inside a loop, until the work is finally done. 30 years after that first definition, perceive and act, the machines finally do both. The while loop made the difference. So the next time software quietly books, fixes, or finds something for you, you will know the shape of its mind. But a mind that acts is still a mind that guesses. Why machines confidently invent things that never happened. That is next.